distribution. Student T distribution. Here T distribution divides into two types. First one is student T distribution and the second one is Fisher's T distribution. First T distribution was defined by W.S. Gossett and it is the pen name of the student T distribution. This student distribution is the pen name of W.S. Gossett given, and this statistic is indicated as small t. Small t. Remember, it's a student T distribution. Small t equal to x bar minus mu by s by root n. Here x bar is the sample mean, mu is the population mean, and the remaining part, this one is the standard deviation. Here x bar equal to sample mean. Sample mean we can represent as summation x by n, and the population mean can be represented as mu only. And next, sample SD. Sample SD can be represented as 1 by n minus 1 summation x in x minus x bar whole square under root. The whole thing will be kept in the root. Next one, n is the sample size. Here small n can be represented as the sample size. PDF of T distribution is given by f of t equal to 1 by root nu into beta of 1 by 2 comma nu by 2 into 1 by 1 plus t square by nu whole power nu plus 1 by 2. This is our T distribution PDF, and here we have two types of T distributions. First one is student T distribution and the second one is Fisher's T distribution. So first we have to write the student T distribution. Before going to that, here T follows the statistic as a student T distribution with nu equal to n minus 1 degrees of freedom. In place of nu, we have to replace the n minus 1 degrees of freedom. Then only will exist the student T distribution. Here f of t can be changed like 1 by square root of n minus 1 into beta of 1 by 2 comma n minus 1 by 2 into 1 by 1 plus t square by, in place of nu we have to replace n minus 1 whole power. In place of this, here n minus 1 plus 1 by 2. Here negative 1 and positive 1 both will get cancelled and the remaining is n by 2. Here also the limits are negative infinity less than or equal to t less than or equal to infinity. We can write one more step. 1 by root n minus 1 into beta of 1 by 2 comma n minus 1 by 2 into 1 by 1 plus t square by n minus 1 whole to the power n by 2. This is our student T distribution PDF. Properties of student T distribution. The limits for student T distribution are minus infinity and plus infinity. And the second property, the degrees of freedom for student T distribution is n minus 1. Distribution degrees of freedom is n. And the next one is, for T distribution, MGF, moment generating function, does not exist. And the next one, if we kept nu equal to 1, this student T distribution changes as a Cauchy's distribution. Let us see that. This is our student T distribution formula. This is our T distribution formula. If we kept nu equal to 1 in place of this T distribution, it changes as here f of t equal to 1 by root 1. It is not able to change. It just keeps same. Beta of 1 by 2 comma 1 by 2. Into 1 by 1 plus t square by 1. In place of nu we are putting 1. So 1 plus 1 by 2. So this T distribution changes to Cauchy distribution. 1 by root 1 is 1. So beta of 1 by 2 comma 1 by 2 into 1 by 1 plus t square 1 by 1 plus t square whole to the power of 2 by 2. So 2 by 2 is nothing but 1. So 1 by 1 by beta of 1 by 2 comma 1 by 2. can be written as pi into 1 by 1 plus t square. This is our Cauchy distribution formula. So, in place of nu, we are taking 1. If nu equal to 1, then it changes as a Cauchy distribution. This t distribution changes as the Cauchy's distribution when we take in nu equal to 1. For t distribution, beta 1 equal to 0 and beta 2 equal to 3 as n tends to infinity. This is our next property. This is our fifth property. Three important applications of student t distribution. Student t distribution is used to test the significant difference between two population means. And the second application is student t distribution is used to test the significant difference between two sample means also. And the last one is it is used to test the significant difference between regression coefficient and correlation coefficient also. First one is population means. Next one is sample means. And the last one is sample regression coefficient and sample correlation coefficients. It is used to test the difference between those two. The t distribution divides in two types. First one is student t distribution. Second one is Fisher's t distribution. Student t distribution was defined by W.S. Gosset, and here Fisher's t distribution was defined by Professor R.A. Fisher. It was defined by Professor R.A. Fisher. It is the ratio of standard normal variate. Standard normal variate can be represented as Z, and it is dependent of chi-square variate. Here, Fisher's t distribution t is equal to Z by square root of chi-square by n, because here the degrees of freedom for Fisher's t distribution is small n. So that with that degrees of freedom only we are dividing this chi-square variate. Next, the PDF for t distribution is f of t is equal to 1 by square root of n into beta of 1 by 2 comma n by 2 into 1 by 1 plus t square by n whole power n plus 1 by 2. And the limits are minus infinity less than or equal to t less than or equal to infinity. This is our t distribution. The PDF of f distribution is f of capital F equal to n1 by n2 whole power n1 by 2 by beta of n1 by 2 comma n2 by 2 into f power n1 by 2 minus 1 by 1 plus n1 f by n2 whole power n1 plus n2 by 2. Here the limits for f distribution are 0 to infinity. This is our first property. And the second property is here the degrees of freedom for f distribution are, it follows 2 degrees of freedom, n1 and n2. So we can take degrees of freedom as n1 and n2. And next property is for this f distribution, mean can be represented as n2 by n2 minus 2. And the variance can be represented as 2n2 square into n1 plus n2 minus 2 by n1 square into n2 minus 2 whole square into n2 minus 4. And our last property is for f distribution, MGF cannot be defined. This is our fourth property. MGF cannot be determined or defined. For f distribution, MGF cannot be derived or defined. And we have some other applications. Two applications are there. First one is, this one is used to test the significant difference between two sample variances. Here we are taking samples from the population, that sample variances can be tested with this F distribution. And the second one is, it is used to test the significant difference between several means. Several means can be represented like ANOVA technique. We are Analysis of variance. Here we can find out many means can from this F distribution.